Hello class, let's go into the fourth application or the fourth problem of applications of quadratic functions. Before we go into this problem, I first want to tell you about what revenue means. So let's suppose you sell a product, I don't know, let's an orange. And obviously when you sell something, that something has a price. And after your day of sales, you're gonna get some amount of money, right, in your pockets. We call that money revenue, okay? And revenue is basically defined as the price of your product or your service, price, times the number of products that you sold, right? Number of sold products. It's roughly speaking, that's what revenue is. Okay, price times the number of sold products, that's going to give you your revenue. And please do not confuse revenue with profit. These two concepts are different, not the same. Profit, what that means is all the net gains, las ganancias netas, the net gains that you're going to get after you discount the expenses from the revenue. Okay, so that's what profit means. It's all is the net gain in money that you will get. But revenue is just how much money you get after your period of selling, which is just the price of your product times the number of sold products. It's a very simple concept. So that's what revenue means. So now that we know that, let's talk about the fourth problem. This is a problem of maximum revenue. Maximum revenue problem. Okay, again, it's a very classical problem in mathematics. So let's see. Suppose that I decide to sell shirts. I'm gonna produce shirts and I'm gonna sell them on the market every Saturday, okay? And I'm gonna start with a starting price for my shirts of 100 pesos. And I go every single Saturday to sell my shirts, my products at the market. And I notice that as long as I keep this price every Saturday, I'm always gonna get 100 shirts sold. I know this is unreal, right? You don't expect to sell always the same amount of shirts, but remember that what we do first is some toy models, some simplified models of reality in order to understand the more complex models. We start easy, okay? Okay, so let's assume that this happens. Every single Saturday we go into the market to sell shirts, and if I keep this price, I always get 100 shirts sold. Perfect. Now, I get a little greedy, right? I go like, okay, can I make more profit? Because my profit with these two quantities, this is my price of my product, this is my number of products sold, so it's just a multiplication of these two, right? And every single Saturday, I'm sorry, I said profit, sorry. My revenue is going to be 10,000, right? At the end of each Saturday. So I'm thinking, can I increase my revenue? Can I increase my revenue? That is the question I ask myself. And I go like this. Okay, let me start selling my shirts for a higher price. And I'm gonna increase the price in 5 pesos next Saturday. And what I'm gonna notice, all of these are suppositions, is that I'm gonna get one shirt sold less. For this price, I'm gonna get 99 shirts sold the next Saturday, and that always happens. If I keep this price, I'm gonna sell these many shirts every single Saturday. Now I do it one more time, right? I increase another 5 pesos, and I notice that I sell 98 shirts. and this continues in the same way. Okay, so basically, for every increase of 5 pesos in the price of my product, I notice that I sell one shirt less than before. Okay, a very oversimplified version of reality, but for our purposes, it will work. Okay, so the question is this. The question for the problem, for this problem is this. At what price should I sell the shirts to get maximum revenue? To get maximum revenue. That is my question. Okay. So why do I say this? I mean, because at some point, guys, you're gonna obviously this is also intuitive. At some point, maybe your increase, your new prices are gonna be so high that nobody's gonna be willing to buy your products, or you're gonna get less shirts sold. Okay, so perhaps if right now at this point, at this point, you get a revenue of 10,000, you say, oh, okay, that's good. And now you try this other experiment, selling them at 105, and you get 99 shirts sold. What's gonna be your revenue in here? Take your calculator, multiply those two numbers, and you're gonna get a revenue of 10,395. And you go like, okay, that's much better than 10,000. And now you try to make the price higher by another 5 pesos. You're gonna sell these many shirts. So let's see how much is your revenue now. Your revenue will be 10,780 pesos. So you see, you're noticing that your revenue increases as you increase the price of your product, but it comes very intuitively that at some point that's gonna stop increasing. Your revenue will stop increasing. I mean, if you keep doing this, you will reach very high prices, and nobody's gonna want to buy your shirt. It makes sense. So basically, an intuitive understanding of what we're doing is this: if this is my price of my product, and if this is the revenue, then the revenue is a function of the product. I'm sorry, of the price. And we can see that if we start, let's suppose this is 100. Okay, this is my starting point. Then I'm gonna get some of this behavior, more or less. Okay, so for this price, for 100 pesos, this is my revenue, 10,000. And then as I increase the price, the revenue is gonna increase until I get to a certain point in which the demand will diminish. Okay, after this precise price, the demand will decrease, and my revenue will go downwards until eventually I reach a price so expensive or so high that not even anybody will be willing to buy my shirt. So that is the intuitive idea. Okay, so what should this price be? This precise price, the price that gives me the maximum possible revenue. That is what we have to do. Okay, so how do we do it? In a very similar way to the other problems. You see that it's the same reasoning for all of these problems. It's the same reasoning. The statements change, the values change, but the method, the abstract method of thinking is exactly the same. So let's see how this works. Okay, first of all, I'm gonna write the following. I'm gonna say that my revenue, as I told you in the intro to this video, my revenue is defined as the price of my product times the number of products sold. So we know this, okay? And I'm gonna label this as my equation 1. And I'm gonna keep it on ice. Let's just leave it there. Okay, now, what other thing can I know? What other thing can I discover from my context in the problem? Well, we can discover, guys, what how the number of items sold changes with respect to price, because as you can see here, the number of shirts that you sell, okay, is gonna depend on the price of the shirt. So let's make a little table over here. Let's write price, and let's represent that by P, and sold items, I'm gonna call that number of sold items or shirts, and I'm gonna represent that by N for number. So for a price of 100 pesos, I sell 100 shirts. For a price of 105, I'm gonna sell 99 shirts. For a price of 110, I'm gonna sell 98, and it's the same for the rest. Okay, so we can see clearly that given this table, I can assess that the number of sold items depends on the price, or in other words, we can establish using the notation function that n is a function of the price. N is a function of the price. Now, what is this function though? What is the equation that defines the relationship between n and p? Okay, it's very simple to obtain, because if you notice, this table implicitly tells you that you have a linear function. If you actually plot these points, okay, I'm gonna plot in here the price of my shirt, and in here the number of shirts that I sell. So for a price of 100, let's put it right here, I'm gonna sell 100 shirts. So I have this point, which is this point. Next, for a price of 105, I'm gonna sell 99 shirts, and let's put it right there. Remember, my drawings are not a scale, so this is done, and so on. For a price of 110, I get 98 shirts sold, which is this point, and so on, right? The pattern keeps going in the same way. So if you notice, this is a straight line, and we know what the function representing a straight line looks like, right? It's gonna be a straight line, and I can get the equation that represents this straight line. That's one of the things we did at the beginning of this topic of functions, right? The equations of straight lines. So let's do that. Let's do that first. Let's do it in yellow. Remember, the equation of a straight line, one of the forms is this one, where these two numbers represent the coordinates of one of the points that live in the straight line, and this number represents the slope. Remember that? And that's why this form was called the point slope form. So let's actually get the equation of this line. Now, in this case, according to my Cartesian plane and my axis, I do not have any x or any y. They are called p and n. These are my variables. My variables are not x nor y. But if you wanna use x and y, you can momentarily think of p as x and momentarily think of n as y. There's no problem. It's just a relabeling. And now we can get the equation of my function. So let's do it. What point am I going to use? Either this or this or this. It doesn't matter which one, okay? So I'm going to choose the first one, this point. This point has coordinates 100, 100. So this is my x1 in here, and this is my y1 in here. So I'm going to put them there. Y minus 100 equals the slope, which I'm going to keep as m for the moment, times x minus 100. Perfect. Now, get the slope of this straight line. I'm not gonna do it for you. It's very simple. Remember, if you have 2 points on a line, you can get the slope. So I'm gonna give you the direct result. You're gonna have to do it on your own. You can stop the video. So the slope will be minus 1/5. You see? So we found this equation of the line. Now let's go back to my original. Well, let's simplify a little bit first. We're going to have y minus 100 equals minus 1/5 times x, and then minus 1/5 times minus 100, that is plus 20, yes. Then y is going to be equal to minus 1/5 of x plus 120 after I add 100 in both sides. So this is my final equation of this straight line. And let's go back to my original quantities, which were p for x and n for y. So I'm gonna use them again. So this is n, and x was p, the price. There it is. So look at these, guys. Look at this. What does this tell you? You have to interpret your equations. The mathematics itself, has no interpretation. You have to interpret what you're doing. What does this equation tell you? It tells you, okay, the number of shirts sold is a function of the price of the shirt, just like we said before. Okay, when the price is 100, and if you enter 100 in there, you're gonna get that the number of shirts sold is gonna be 100, just like this precise line tells you. When you enter in here a price of 105 pesos, this n will be 99. The number of shares sold will be 99. Make sure of what I'm telling you, okay? You can pause the video anytime. That's one of the advantages of the video, right? So this is this is how n is a function of p. So let me erase this. Okay, and how does this equation help me now? In the following way. I'm going to erase this part over here, no longer needed. So we're working from left to right, and after I'm done with my space, I go back to the beginning. You see how mostly, I'm not going to say that I'm always perfect in this sense, but I always work in the same way. I work from top to bottom and from left to right, and I make divisions, you see, in order to tell my reader what's next. I don't work all over the place. In most cases, I know that sometimes I don't do that, but as much as I can, I try to be very ordered in my reasonings. You have to think about your reader when you write. You're not writing for you, you're writing for a reader, for a potential reader. Okay, so how does this equation help me now? Now, by the way, let me call this equation equation 2. Remember, try to label always your equation. That's another great thing. So I have this equation 1. I have this equation 2 that I have discovered. And now, again, just like before, I can combine my two equations. I'm going to combine them. So, in what way? Let's keep working with yellow. So, the revenue equals the price times n, the number of products sold. But I'm going to put this n. You see, n equals all of this thing, all of this. So I'm gonna copy this and paste it in here. That's the trick. That's the trick that's gonna solve the problem. You're gonna see why. Okay, so I have this. Let's simplify a little bit. So p times this term, I'm gonna get minus 1/5 of p squared. P times this number will give me 120p. Okay, so look at this. What, again, let's go for the interpretation of this equation. What does this equation tell you? It tells you the revenue that you're gonna get at the end of the day, each Saturday, is gonna be a function of the price of your shirt in this particular way. Okay, so we say that the revenue, let me continue with white. We say that the revenue is a function of the price, just like we said before. Now I want you to understand this other idea. This is a little complex, so pay a lot of attention, please. What are my two quantities being related? The revenue depends on the price of the shirt. Okay, so we say that the revenue is a function of the price. Now, F F is the name of the function, guys. These are your two quantities involved, this one, and they are related through a function that I'm calling f. The name is not important. I could have written that revenue is a function g of p. This name is not really important, okay? It's just the name of the function that I'm producing. Now, a lot of people, a lot of mathematicians, a lot of scientists, etc., they try to make this relationship explicit in a better way. They're gonna call the function itself, okay, I have been calling f. They also call it in the same way as your dependent variable, okay. So they do something like this: the revenue is a function r of p. Why is this probably a better idea? Why? Because now I can write this: the revenue for P, or the revenue of P, is equal to, obviously, this one minus 1/5 of P squared plus 120P. And this is more readable than writing something like this, than saying the following. I need you to I need you to understand this very good. If I write this, f of p equals minus 1/5 p squared plus 120p, and then I tell you, okay, f of p, by the way, f of p is the revenue. You see what I mean? When somebody reads this, uh, the it's not clear by writing this, like, what is your dependent variable. We know that the independent variable is the price, but what is changing, what variable is changing as a result? Because here I'm just calling the function f, but I don't know what variable is changing as the price changes. But if I write this, though, if I give the function itself, if I give it the name of my dependent variable, which is revenue, I'm saying that by all of this, when you read it, you understand that your independent variable is P, the price, and your dependent variable is the revenue. You see? So all of this already contains that information. The revenue is a function of the price in this way, in this particular mathematical algebraical way. So both are okay, but I want you to be aware that you can call the function in the same way as your dependent variable, and in most cases, um, that's a better idea, a much better idea, and it's very frequent to do in mathematics. A lot of people do it this way. So when I do that, don't get confused. So let's actually do that just for practice. So my revenue is a function of the price of the shirt, and I'm gonna write that R of P, or R, the revenue as a function of the price, is given by the following mathematical expression. Perfect. So this is my function written in this new type of notation, so to speak. Okay, so the rest is very simple. Well, once we get to the function, down to the function, the rest is simple. Why? Okay, because we know that if we, being this a quadratic function, with a coefficient, with a negative coefficient for the p squared, this will behave as a parabola which opens downwards. This is my price, this is my revenue, this is my starting price of 100 right there. For 100 of price, if you remember, we got 10,000 in revenue, and all I need to do now is find that precise price for which I get maximum revenue. And that precise price and that precise maximum revenue happens, as it's very understandable visually, at the vertex. at the vertex. So all I need to do is get the coordinates of that vertex, this coordinate and this coordinate, and I'm done. By doing that, I will find for what price my revenue is maximum. So let's do it very quickly. This is going to be coordinate Vx, Vy, and as we know, the x coordinate of the vertex is given by minus b over 2a. What is b and what is a? My coefficients in the function. So b is 120, so it's going to be minus 120 over 2a, where a is minus 1/5. So I'm going to get, when I multiply them, I'm going to get minus 2 over 5. And divide this thing, please. You're going to get, let's do it. You're going to get 300. So that is the coordinate, the first coordinate of the vertex, 300. And what does that mean? Basically, we have solved the problem, right? Because that means that for a price of 300 pesos, I get my maximum revenue. Okay? And what is that revenue going to be? It's going to be this coordinate. Let's calculate it. It's basically the function evaluated in this number, right? F evaluated in 300. So, well, not F, right? In this case, we changed the notation to R. The revenue up for the price of 300. So just input 300 in here, 300 in there, calculate this stuff. Let's do it. And we're gonna get 18,000 pesos in revenue. 18,000 pesos in revenue, and so that's a lot of revenue. Okay, that's a lot of increase because we started selling them at 100 pesos, getting a revenue of 10,000 pesos, and if we increase the price to 300 pesos, now my revenue is 18,000. It's almost the double, you see. And but after that, after 300 pesos, the demand is gonna go down, and my revenue will also go down. And for if I get too greedy and I start selling them at a very high price, which is this one, I'm gonna get even zero revenue. Okay, guys. So as you can see, it's the same process of thought as the ones before. Of course, this one is a little more complicated. Study the problem. Study it. You have to pay a lot of attention. You have to pause the video. You have to do the things I do, etc. And if there are questions, ask me. And that's it. Okay. I want you to solve all the problems, the remaining problems on the first workbook of applications. I think that you're already prepared to solve them all. And that's it, guys. Thank you so much.